Y'all good on what we've done so far? Everybody know how to take a derivative of a 2 by 2 and a 3 by 3? Not a derivative. That's calculus. Does everybody know how to take a determinant of a 2 by 2 and a 3 by 3? Using the diagonal method stuff we learned? Does everybody remember how to do an inverse?
Yes.
So, real quickly. 3, negative 4, 5, 7. What would that tell you to do?
7 times 3.
21.
Minus
a
20.
negative 20, which is positive 41. Everybody good?
Yep.
All right, what would this tell you to do?
Do the little video game thing.
Okay, so I like to make 6 parentheses to go have it all set up. So I realize I'm going to have the 3 diagonals coming down and the 3 diagonals coming up, which are all going to be negated. So the first diagonal,
0.
0. Second diagonal, and listen, if you want to recopy columns, knock yourself out. Okay, I don't like it, waste time for me. But do it if it helps you. If you're like, man, I am so error prone, I missed 20 points on careless errors. Take your time, okay? But the next diagonal would be that times that. So positive 6. The next diagonal would be 3 times
5 times 2.
So 3 times 10. Those are the diagonals down to the right. The diagonals up to the right would be
negative 12.
Negative 12, and look, you already have that other negative in there, so it's one less thing to think about. The next diagonal would be 2, 6, and 2, which would be 24, and then the last diagonal is 0. And then double negatives become positives, and you end up with 36 here. Minus 24 is 12, plus another 12 is 24. And if you set this up and you make a careless error, I can at least see your error and dot you instead of slashing you or Xing you over. And then the last thing, just review, if I told you that A was, say, this matrix, and I said, what is the inverse of A? What do we do to find an inverse? We switch those, switch the signs of these, and then one last thing. Multiply by 1 over the determinant of that, which would be 2 plus a 15, or minus a negative 15, which would be 17. So my final inverse would really be that multiplied in. So if I ever ask you for what the inverse is, go ahead and clean it all the way up and say, oh, 1/17, 3/17, negative 5/17, 2/17. But the reality of it is it's probably easier to use the inverse with that on the outside, because then you don't have to deal with these ugly fractions. And how would you use the inverse? This was the last thing we talked about. We use it like we use a reciprocal. How do we use a reciprocal?
To divide.
To divide. Okay? So just like if you had an equation like 3x equals 15, and you would multiply by the multiplicative inverse, the reciprocal. I know you would divide, but pretend there was no division. Just like you would multiply by the reciprocal to get 1x, and 1x times anything is x, if you had a matrix equation, and see how these are paralleled, with a matrix equation, like there's an x, that's like your 3, that's like your 15, we're still going to multiply both sides by the same thing. But we're multiplying by something that will make this go away. Just like I chose 1/3 to make the 3 go away. But instead of ending up with a 1, what am I going to end up with? The identity, right? But what do I have to multiply both sides by to make this happen? So I'm going to put the inverse here and the inverse here. Give myself a little more room. And I am going to copy this other junk down. So this comes down, 3, negative 1, 5, 2, drop the x. And then this comes down. And why is it important? We'll really see who's watching the videos. Why is it important that I put the inverse on the left of both sides?
That way you're multiplying by the same way.
Because the commutative property didn't exist, right? Because here it's okay to put 1/3 on the left and 1/3 on the right. That's saying A times B equals B times A. But that's commutative properties fine with scalar numbers, regular old numbers, but not with matrices. All right? So you'd get an answer, you'd just be wrong. And that's a big deal on this problem to me, so you'd really get hammered. Okay? I mean, you get credit for finding the inverse, but that's about it. So I find the inverse of this one, which is switch, change the signs, and then what do I get? 6, and then the determinant on the outside, 6 plus 5 is 11. Now don't take the inverse of this and put it there. Remember, I'm doing the same thing on both sides, right? So I'm going to copy that over here, 2, 1, -5, 3. And what do I know is going to happen here? All of that's going to multiply and give me the identity element. Except the identity element with matrices is not 1, it's 1, 0, 0, 1. Now I would encourage you to do the math. Unless you were in a really big hurry on your test and thought, I'm not going to have time to finish my test. Because by doing the math, check it out, row, column, 6, 5, row, column, -2, +2. Row, column, -15, +15. Row, column, 5, 6. Drop the 111. There it is. When I multiply that in there, there's my 1, 0, 0, 1. It's just a nice check. But what is the identity times anything? It. That thing, right? So for those of you that go, man, I'm not writing that out. I know how to find an inverse. I know how to multiply correctly. I am not worried about careless errors. And there are some people in here who make very, very few careless errors. But if you are error prone, like if you're the guy that's like, oh yeah, I would have totally forgotten that 111, you would have caught it. Because when you multiply, you're like, wait a minute, that's not the identity. But it looks kind of like it. Oh, if there was a fraction out front, that 11 would have changed to 1. I forgot my fraction. Maybe that would happen. But if you're like so on it, you're like, man, I know I'm not going to make a careless error. Technically, you could say, hey, you could just put the inverse on the inside here and just write x. Because that's what's going to happen. Now, I still need to find my answer, right? And this, again, is why I don't multiply the 1/17th in, or the 1/11th in, because I kind of like dealing without fractions, if possible, as long as I can. So let's multiply rows, columns, and be careful here. 12, -2. 10. 2, 3, 5, -30, -6. And then finally, -5, 9. And then the last thing was multiply that 1/11th in. So now I multiplied it in, and I've got ugly fractions, but I didn't have to deal with them until the very end. And that sounds good to me. Now another option would be, hey, I know I'm right. When I multiply by the inverse, I know I'm going to end up with x. Well, I guess what you could do is just take your answer and check it. If I take my answer and put it right there, shouldn't this times that give me this? Yeah. So I guess you could do that too, or you could just hope you don't make an error. But if you do make an error and I see this check, then I'd probably grade a little lighter because I'm like, well, they are doing everything I'm asking. So just be right if you're like, hey, just kind of like up here. I know people all the time that don't show this step. They go, hey, I know that when I divide by a 3, and they just do this. Or they go, hey, I'm going to just divide that by 3. They show the work on the right and just say x on the left. You can do that if you want. I'm just telling you, a lot of people make errors, and it's good to catch your error if possible. You with me? The most missed question on your test every year. Just saying. All right, here we're going to do a little bit different today. We're going to do something called expansion by minors. And this is how I like evaluating determinants. And for some reason, this used to be a big deal to people, but as the years have gone on, people have started going, you know what, I kind of like expansion by minors better. And this way, I don't have to learn a rule for a 3x3 and a 2x2, and then learn something different for everything else. So this is how expansion by minors works. It's not overly difficult, and it's going to seem really lengthy when I explain it, but then when I do a couple, you're going to go, oh wow, that's really not that much work at all. In fact, I like it because it's really easy for me to set this thing up, and I can do a whole lot more in my head than I would have been able to formally. So check it out. I'm going to put a generic one up here. I'm going to call it A, B, C, D, E, F, G, H, I. And not the imaginary number I, but just some random variable. So this is what I've been saying. The word, it's expansion by, technically, it's called minors and cofactors. But most people just say expansion by minors. All right? So here's what you do, and it's not going to make any more sense than the diagonal method, but check it out. So, pick any row or any column. Most people pick the top row, and when they pick the top row, they can do all of these the same, although sometimes there's an advantage of picking a different row, which we'll talk about later. But let's just say I pick the top row. If I pick the top row, I'm going to take those, each of those numbers right there are called cofactors. Okay? So each of those numbers are cofactors. So to simplify this, I'm going to write down each of those numbers, but I'm going to leave some space for a determinant. And the determinant that I'm going to multiply by A is 1 degree less than the original. So if the original is a 3 by 3, the determinant you're going to multiply by A, which we call its minor, okay, will be a 2 by 2. So I'm leaving me enough room for a little 2 by 2 right there. Then I'm going to copy B down, put it over here. I'm going to leave a little space for a sign, like a plus or minus, and put another determinant. And then I'm going to copy C down and put another determinant. And you're going to see in a second, this is going to seem really long, but it's not going to be as hard as it seems as the explanation seems. So here we go. First thing, each of these letters, A, B, and C, needs to be multiplied by this. Needs to be multiplied by -1 to the row plus column that it's in. Now, what row and what column is A in? First row, first column? What's -1 to the 1 plus 1? Did y'all hear that again? Each A, B, and C needs to be multiplied, and I'll show you a better way to do this, needs to be multiplied by -1 to its row plus column space. Now, since it's in the first place, first row, first column, 1 plus 1 is 2. What's -1 squared? +1. So I'm going to multiply that by a +1, which essentially does nothing, does it? Doesn't make it positive, it just doesn't change anything. Are you tracking with me? That's a positive, that's supposed to be a +1 right there. Now, let's look at the B. The B is in the what? First row, second column. What's 1 plus 2? What's -1 cubed? -1. So here, I'm going to multiply that by a -1, which changes the sign of whatever B is. And then finally, C is in the what? First row, third column. 1 plus 3 is 4. -1 to the fourth would be +1. So here, I'm going to multiply C by a +1, which does nothing. Now, if you think about this, the top row is going to get multiplied by a what? If you chose the top row, you're multiplying by a +1, -1, +1. But what if you pick the second row? Then it ends up being a -1, +1, -1. Or if you pick the third row, +1, -1, +1. What does that remind you of? Anything?
Pascal's pyramid.
What?
Pascal's pyramid.
Plus, it reminds me of a checkerboard, kind of. Tennessee end zone. All right? It looks like a bunch of alternating patterns, like red, black, red, black, or whatever. Just looks like it's alternating, like a checkerboard or whatever. You kind of follow me? Well, most people just like going, I'm just going to pick the top row. If I always pick the top row, it's plus, minus, plus. So basically, you're just changing the middle sign. And if it was a 4 by 4, I guess you're changing the fourth. But sometimes it's beneficial to maybe pick the third column. If I pick the third column, it's also a plus, minus, plus. If I pick the second column, it's a -1, +1, -1. And again, don't be confused with making it negative versus multiplying B by a negative. The -1 really just says change the sign. The +1 says leave it alone. Are you all with me? Now again, the explanation for this is long, but once you know how to do it, you're going to see it's really quick, okay? And much less writing and thinking, in my opinion. All right, now let's fill in these. These are called minors. The minor of A, and I'm going to erase this blue stuff. The minor of A is everything that is not in the row in the column of A. So what is not in A's row or A's column? E, F, H, I. So plug that in there. E, F, H, I. What's the minor of the B? D, F, G, I. D, F, G, I. And the minor of the C? D, E, G, H. And this is it. All you have to do now is clean it up. And you know how to evaluate a minor, right? I mean, by a 2x2 determinant. You just go that times that minus that times that, get your answer, multiply it by the A times the positive 1. Here, that times that minus that times that, get your answer, multiply it by the negative 1 in the B. Here, multiply DH minus EG or whatever, and then multiply it by the positive C. Let's see an example. Most of y'all like examples. So check it out. 2, negative 4, negative 6, 1, 3, 5, 2, negative 8, 7. Pick a row or column. Top row. So I'm going to take the 2, minor. I'm going to take the negative 4, minor. I'm going to take the negative 6, and it's minor. And then what am I going to do to the 2? Keep it the same, positive 1. What am I going to do with the negative 4? Multiply by a negative 1, which does what? Changes the sign. And what are you going to do with the negative 6? Multiply by a positive 1, which leaves it the same. So basically, just change the sign of that middle term. What's the minor of the 2? 3, 5, negative 8, 7. What's the minor of the negative 4? 1, 5, 2, 7. What's the minor of the negative 6? Now, if you're looking at this right now and going, this is way more work, hold on. If I did it this way, it might be. Do the math. So the minor here is 21 minus a negative 40. 21 plus 40. All right? The minor of this, 7 minus 10. Negative 3. And the minor of that, negative 8 minus 6. And what do you have left? 122 minus 12 plus 84. So what's that? 110 plus 84, 194. Now, a lot of you right now go, man, I'm diagonal method all day. And that's fine if you want. But let me show you how I do these. And I think you guys, some of you will be able to see this. I can visualize the minor. You are visualizing it, right? If you can visualize it, then you can do that math in your head. Or at the very minimum, instead of writing 61, you might say 2 times 21 plus a 40. Check it out. 2 times its minor. I can visualize that's the minor. So I can say 2 times 21 plus 40. Bam. I just jumped there. Then I can say, all right, the 4 I'm going to change the sign of. What's its minor? These 4 numbers. 7 minus 10. There's the last number. I don't change it. What's the minor there? This. Right? Is it negative 8? Yeah. Negative 8 minus 6. Negative 14. So when I'm doing expansion by minors, I'm jumping to right here. In fact, most of the time I don't even need to do that. I can do a lot of that in my head. Yeah, thanks. Are y'all tracking with me? Yes, no? Okay. So again, if I showed you this, and again, I do not care which way you use on a 3x3. I am going to, on a test, give you one and say, show me you can do this with expansion by minors, just to make sure you know the process. And honestly, what I'll probably do is just say, set up what you would do. But it'll be a bigger one, like a 4x4. Okay? Let me show you one more time. What if I gave you 5, negative 1, 2, negative 3, 4, 7, 1, 0, negative 4. Now, what if you said, wait a minute, there's a 0 in that row or 0 in that column? What would a 0 do if it was a minor? It would cancel out all that, wouldn't it? That might be helpful. Now, if you don't choose that, then you're just going to end up with the 0 in a bunch of your minors, which is also good. But I kind of like picking this. So I'm going to pick that row, and I'm going to say 1 times its minor. I'm going to do the minor in my head. 0 times its minor goes away. -4 times its minor. Are y'all tracking with me what I'm saying? Now, would I be keeping plus, minus, plus here? If it was a big checkerboard, 5 is positive. Don't change it. Negative, positive. Are you tracking with me what I'm saying? Or you could say, hey, that's in the 3rd row, 1st column, -1 to the 4th is positive. Don't change it. That's in the 3rd row, 3rd column, -1 to the 6th is positive. Don't change it. So I'm not changing these. Now, if there was a number there, I would change it. And again, you don't have to choose this row. I'm just picking a row that has a 0 because it might save us some time. So what's the minor of 1? It's that, isn't it? Do the math. -7 minus 8. That's where you got to be careful, right? -7 minus the 8, -15. That's all I need to see. What's the minor of the -4? 20 minus a 3. Careful. See how you can make a mistake? 20 minus the 3? 17. -15 minus 68, -83. That's quicker than doing the diagonal method, to me. But I want you guys to know, you'll have time on your test to do these, but you're going to need to be able to do this method. And let me show you a nice way you would see this, where you cannot do the diagonal method. So check this out. Evaluate the minor. Now there is no diagonal method here, is there? Do you see a preferable row or column that you could use? The first column? I'm all over the first column, because the first column is riddled with zeros. And every 0 that is a cofactor is going to make the minor go away, isn't it? So all that's going to be left is a 2 times its minor. Now 2's minor is going to be, if this is a 4 by 4, what's the minor of 2 going to be? A 3 by 3. I'm not doing that in my head. All right? So I'm going to, and by the way, is 2 in a positive or a negative spot? Plus, minus, plus. So it's in a no change spot. Or you could say 3rd row, 1st column. What's -1 to the 4th? +1. So I'm not changing the sign. But looking at this, what is not in the row or column of 2?
2, 8, 5.
2, 8, 5.
4, 1, -6.
4, +1, -6.
4, 6, -5.
4, 6, -5. And at this point, do we know how to do a 3 by 3?
Yes.
And that you'd have some discretion on whether you want to do a minor or whatever. So here's what you have to be careful about that 2. Don't forget that that 2 is still out here. But at this point, you could do the diagonal method and get that and then multiply the whole thing by 2. Or I'm going to do expansion by minus. Check it out. 2 times the minor of 2. What's the minor of 2? -5 plus 36. What's a positive 36 and a -5?
31.
Bam. Change the sign of the 8. What's the minor of the 8? Those two. -20.
Minus 24. Or minus -24.
Plus 24. So -20, positive 24. And then the 5? 24 minus 4. So do the whole inside part. 62 minus 32 plus 100. So what's that, 130? So 2 times a 130 is a 260. Y'all seen this? I'm a huge fan of expansion by minors. I like it. I rarely do the diagonal method anymore. But listen, there's no shame in doing it. It's in your textbook. I mean, obviously it's a useful tool. But remember, the diagonal method is only going to work for a 3x3 and I guess a 2x2. How about this? Did you ever think about the expansion by minors with the 2x2? What would expansion by minors say? Pick a row. What's the minor of the 3? Okay? And then change the sign of the 5. What's the minor of the 5? There's your rule. 3 times -1 minus the 5 times 4. So expansion by minors works on anything. 2x2s, 3x3s, 8x8s. And tomorrow, still got some time. Tomorrow I'm going to show you all these tricks that start showing up on math tournaments. Because if expansion by minors requires you to do a 3x3 for each cofactor, potentially that can be how many 3x3s? It could be 4 of them if I pick that column, right? That's a lot of math. Well, what if I have a 6x6 determinant? That means you're going to have 6 what? 6 5x5s. And each 5x5 is going to have what? 5 4x4s. And each 4x4 is going to have what?
4 3x3s.
4 3x3s.
No.
I would never do that to you unless there was a trick.
Oh.
And math tournaments are all about little tricks popping up. And most of them you're able to do just with expansion by minors. And if you can learn some of the tricks, you don't even have to do expansion by minors. You can, like there's a little small one. Let me just show you. We've got some time, right? So check this out. What if I gave you 2, -1, 3, 5, 0, 3, 4, 7, ooh, 4x4. That could potentially be 4 3x3s, unless you choose wisely.
Bottom. Oh wait, far left.
So you could use the bottom row, or maybe the left column. Either way is fine. The only advantage maybe with using the first column is you already know 2 is in a positive spot, right? Whereas you have to go plus, minus, plus, minus, plus, minus, plus to figure out what that last one was. But if you just chose the first column, you would say, oh, well, my answer is just 2 times what? The 3x3 minor of 2. And then I could ignore all these other zeros because it would make their minors go away. What's the minor of 2? Careful. Nothing in the row or column. So what is it?
4 7.
3 4 7. 0 5 2. 0 0 -6. Well, at least I got it down to a 3x3. How do you want to do this 3x3?
Far left column.
Far left column again. Great idea. So I'm going to drop the 2 down. How do I do the far left column? Now 3 is in a positive spot, right? Because it's the top left now. 3 times what? Its minor. I'm going to go ahead and write it out this time, just for you to see something. So I've got 2 times the 3 times its minor. Now how do I evaluate this minor?
Another one.
You could, or you could just do your 2x2 rule, which is pretty easy, right? 5 times that minus nothing. What do I end up with? 2 times a 3 times a 5 times that? What is that? Oh, so you're saying if in the original problem I see a diagonal, now what's important is you don't get sloppy. If I see a diagonal moving from the top left to the bottom right that has zeros below or zeros all above or both, I don't have to do all this. I can go 2 times 3 times 5 times -6. Done. And that's the first rule we'll learn. And that's no matter how big the size is, if what? There's zeros and what? It's coming, the diagonal's coming in that way. Now, you're going to learn tomorrow if the diagonal, maybe, or maybe in a few seconds, if the diagonal's going up this way, it's not true some of the time. Now, what if I threw you a curveball? Instead of putting a 0 right there, or a 0 right there, what if I made that 2 a 5? Well, I can't do the diagonal method, right? And I would also, if I picked that row, mean what? But I could have picked this instead, couldn't I? Right? So I could have picked this instead. Right? And I could have gotten there. So let's just say I picked the bottom column and the bottom row instead. I would have -6 times its minor. Are you with me? And it's in a, since that's in the 4th row, 4th column, it's -1 to the 4 plus 4, -1 to the 8, so I don't change the sign. Or you can go plus, minus, plus, minus, plus, minus, plus. Don't change the sign. What's the minor of this?
-1, 3, 5, 3, 4, 0, 0, 5.
And if you were going to evaluate that 3 by 3, what would you probably pick? 5. And again, it's in a plus, minus, plus, minus, plus spot. So you got now a -6 times a 5 times what? 5's minor. 2, -1, 5, 3. And at that point, you can do it, right? So you end up with a -30 times a 6 plus 5 minus a negative plus 5. So -330. Expansion by minors is the way to go. But with the 3 by 3, if you got to here and you went, you know, I just like the diagonal method, then fine. 30, 0, 0, minus 0, minus 0, minus -25. If you want to do that, knock yourself out. What did I do wrong? Nothing. 30 plus 25 is 55, and -6 times 55 is -330. Right? So you're welcome to do the diagonal method when you get down to a 3 by 3. But man, wouldn't it kind of easier doing expansion by minors? So I really like it. There's just, especially in math team land, where we live in this land where everything looks uglier than it is. That's the main goal. Have we talked about assuming the position in here? I've never talked to y'all about this. You ever seen the movie Dead Poet Society? If you haven't, it's a good movie. Anyway, really good movie. But at the end, these guys got in trouble and they paddled them, and it brought back a memory, like a scarring memory of mine. And they went, assume the position, and the guys had to like bend over and grab their ankles, and they took the paddle out and started paddling. Well, that was my junior high. And in junior high, 7th grade, I'm like 4'11", 85 pounds. And they walk in there in PE class, and if you're late, you got what they call a lick. And they called it a lick. And a lick was, they took these paddles, well, they created paddles. The gym shop guy was like making these like they were candy. But they took plexiglass, 1/2-inch plexiglass, cut it into like a 2-inch paddle, grooved a handle on it, taped the handle up for grip, you know, because you can't let go. Drilled holes in it to make it look more intimidating. And they would bring you up there for being late, just late to class. Assume the position. And in gym class, there's like 70 kids with the little, you know, this is 1980, little short shorts like right here, and the striped socks up to your knees, old school. And you walk up there, and literally it was like you were in the Colosseum of ancient Rome. And like the whole room's like, ah! I mean, cheering on your demise. And you would say, assume the position. And they would take these paddles, and I'm not kidding, they didn't just like smack you, they tried to destroy you. And they would take this thing and be like, and these guys, I think they worked their forearms out, you know. They would come in there, and it was like a golf swing. They would be back here and just wham! And when it hit you, you would have to step forward to keep falling over. And you would feel nothing but like a lightning bolt to you. And then it went all numb for like an hour and a half. But it was excruciating. But they did that back in the day. Well, the reason I mention that is because you're at your most vulnerable when you just go, I assume the position, you know, and you just grab your ankles and let somebody wail on you. That's what math problems are trying to get you to do. Quit. Give up. All right, let me just take mine and move on. We're not going to do that. we're going to constantly look and have the mentality of a rat in a maze. And a rat in a maze, when you dump him in there, he didn't just go, ugh, and curl up into the fetal position and die. He sniffs around and tries to pull down the curtain a little bit, right? And have a better look at it. And if you can do that at math tournaments and not be intimidated by 7x7 determinants or 6x6s and go, wait a minute, they're disguising this so that I'll just quit and assume the position, right? No. Most of the time, if you just sniff around a little bit and you can pull off that exterior cloak that makes it look bad, you're like, ah. I mean, I audibly hear it from my students a lot of times when I go, or maybe even one of you on this when you're like, oh yeah, if you just keep doing this, you start seeing the pattern. And most of the time, for you guys, you see a very cleverly created problem that you maybe haven't seen exactly before. If you can just pull down and get a peek beyond the curtain and not assume the position, you got a great shot at doing really well on these. I literally look at a problem and go, okay, I know it's not this bad. And with training, hopefully you guys will get there. All right? And what do we got? 7 minutes? Y'all smell that?
I have to pee myself.
Smell a power quiz.
Oh,
All right, let's see what you got.
Bro, whoa, wait, hold on. Hold on, wait, this is a thing?
All right, now this will not count,
Yo!
but I want to show you what you're looking at when they do count. So do not turn this over. So don't turn it over. You can write your name on it if you want, and you can use this to kind of give you an idea what's going to happen on these future ones, because I'm going to use these exact same problems, but just put them in different orders. All right, so don't flip it over yet.
So you just work until you're finished.
Do what?
Just keep going until you answer all of them.
Okay, here's what we're going to do. I'm going to turn this off because I need my phone. We're good.